Hi everybody, my name is Mackenzie Heal, and I'm here to present some recent data using two replicable multi-step biomarker network analyses. And just before we get started, I want to thank our funding agencies for providing support for our research. It has been long established that AD etiology is highly heterogeneous and multimodal. Depicted above here, we have some mechanism-specific groupings of key AD genetic markers. Of interest to our current study is bridging integrator 1 or BIN1 that is involved in tau metabolism, and TREM1, which has a role in immune and inflammatory response, both of which we've incorporated into these analyses. Using 44-year trajectory data from the Victoria longitudinal study, we applied conditional longitudinal growth models to test predictions of biomarker network for memory levels, the intercept, and change using the slope. The analytic sequence was pulse pressure, we did first, genotype moderation separately for BIN1 and TREM1, and then we stratified by sex. First, we do BIN1. We first stratified the PP fan effect by BIN1 genotype and found that lower risk groups, so CC and CT, exhibited conformationally similar patterns, but no moderation for the highest risk groups, the TT carriers. Next, we stratified by sex and observed that male and female CC carriers have conformationally similar biomarker fan effects, but drastically different level and slope. Looking at CT carriers, females with one risk allele have continued protective effects of good pulse pressure, but males in the same genotype see no differential effects of pulse pressure, including no apparent protection from good vascular health. And finally, for TT carriers, there are conformationally dissimilar patterns with exacerbated decline for high genetic risk males with the worst pulse pressure health. In the next study, we did the same analysis, but we used TREM1. So in column 1, again, we see that we stratified by TREM1 genotype only. And again, we see some conformationally similar pulse pressure biomarker fan effects. And however, across genetic risk status from higher to lower, females tended to be less affected by TREM1 genetic risk than males. Notably, with increasing genetic risk, the female showed emerging fan effect patterns. Compared to females, the male patterns did tend to show generally lower level and steeper declines. So when tested as independent predictors, AD biomarkers tend to be inconsistent in detecting differential cognitive decline in asymptomatic aging. But with longitudinal data, we can test a dynamic network representing the successive moderation effects of genetic risk and sex. And multimodal interaction analyses such as this, informed by mechanism information and stratified by sex, is a very promising method for enhancing precision AD risk assessment. Thank you very much, and these are our references.